Hey everybody, welcome back to the next video. This is going to be the center of rotation video. And so center of rotation is, going to be the lowest that you're going to want to let your life get to. If you have to do the method we did in the 3+2 video, you should really reach out to someone because that's no way to live. So it's actually not too difficult, pretty easy to convert our program from the 3+2 to the center of rotation. So the first thing we'll do is open up our 3+2 file. And so what we're going to do now is we're going to take all of our toolpaths that we've created and we're going to reference the same coordinate system to all the toolpaths so that we can use just one offset instead of 5 different offsets. So first thing, I'm going to hold the control key and select all of the toolpaths in setups 2 through 5, and then I'm just going to left click, hold, and drag it. Alright, so now all the toolpaths are in the first setup, and so they will reference the coordinate system that setup 1 is tied to. And then I'm going to just go ahead and delete the rest of these setups. Hold the control key, select each of the setups, and hit the delete key. Alright, so first thing now, in the setup, coordinate system is up here, top of the part. And so we're going to use this point right here, which is the center of rotation. If you look in the model for the TRT sketches, oh, sorry, it's in yours. This is a separate file for my videos, but in yours it'll say core, center of rotation, for the sketch point. All right. Hide that. Do a right click, edit. So now my origin, I'm going to hit the drop down and I'll choose selected point. And I'm going to choose this point right here. Okay. So now I'm going to go down and I'm going to generate these first toolpaths for the top. Okay, so now this one, right click, edit. And so on the multi-axis tab, I need to select tool orientation. So Z-axis and X-axis is already selected. So what I want to do is I want to choose this for Z and this for X. Okay, and then my origin is my setup WCS. All right, so that keeps everything at G54, one work offset. Okay. And now I'll do the same thing for this chamfer. Go to my multi-axis tab, tool orientation, Z, and X. Okay. Now move to the triangle face and do the same thing. Tool orientation, Z, X. Okay. Z, X. Okay. And lastly, diamond face. All right, then I'm going to go save as. Laney Cube COR. So now when we, let's see, before we post, we need to go to the manage machine. And we're using pause VF2. This one here, right? Okay, so before we post, we want to go into our Haas VF2 machine here, do a right click edit machine, because we need to come in here into the kinematics, and under the A axis and the C axis, this TCP, we need to uncheck that. If we leave a check mark there, then the post processor thinks that the machine can do tool center point control, and our VF2s cannot do that. So if it sees the code for that, then it will alarm out. So we uncheck the TCP from the A axis and the C axis here. Okay. Another thing that we can do at this time, if we, looking at our toolpaths here, it kind of made sense to have them in this order when we were doing, 5 different work offsets. But now we just have the one work offset, so it's if we think, if we look at it, we have all these tool changes, right? So if we could group these tool paths by their tool, then we could save a bunch of tool changes, save a bunch of time. So I'm going to grab these. I'm going to hold the control key and click on these tool paths here with tool number 3. So tool 3, tool 3, tool 3. And then I'm just going to drag them up right below tool 3 the first time. So now I got all my tool 3s together and then all my tool 4s together. And then one thing I think what I'll do is take this deburrs the top, right? So I want that actually to be last. I'm going to drag that down to be my last toolpath. That way, when the program's done, the part will be back to vertical again, and I don't have to mess with any home codes. All right, so we got all of our toolpaths. Now, one thing we have to consider is, so what's the tool going to do while this thing is rotating around? We don't want any crashes, right? So we'll talk about that when we post. There's a nice little feature that Fusion has for a safe retract. Okay, so we got the machine edited and we got our toolpaths grouped. So now we can post. All right, so I want to choose again pre-NGC. And then in my options over here, let's go through this a little bit. We don't have chip augers, so we don't want to check that. Fast tool change, we don't need that. Let's see, we don't need that. Option stop is good, we want that. Let's see, preload tool, no, we don't have a arm changer. That's good for the UMC. Okay. Use G0, yeah, we want that. Use G187 should be off. And then this one here, you want to make sure you don't check this one. You don't want it to, you don't want the tool to go X, Y home every tool change, okay? And then safe retracts, you want that. This is what's gonna make it so that our tool doesn't crash into the part or the TRT while it's rotating to our different positions. So we have options here, G28, G53. G28's a little more normal than G53, but either one would technically work. I'd like you to use G28. The other option is clearance height, right? So what G28 and G53 are going to do is before the TRT rotates, um, it's going to send the tool up to the home position, so the top of Z. Um, and for some rotations it doesn't really need to go that high, so you might be sacrificing a couple of seconds by using this G28, but it's a lot safer. If you choose clearance height, then you got to go and make sure that the tool paths at each of your rotations have a clearance that's going to not cause a crash. All right, so we'll select G28 for that one. Let's see. All this stuff is fine. Don't need to mess with any of that. Okay. Post. All right. So here's our code. G54. Good. A0, B0. Okay, this is our half-inch end mill here. And here's our quarter-inch end mill the first time. A0, B0. All right. It's contour number 3. And then, okay, contour number 5. So this is the first time where we get rotation, right? So A90, B0. You see what happens up here, though? It goes to G28, G91, Z0. So this is the code that's going to send Z up to like tool change position or home up at the top of the Z travel. Okay. Then it's going to rotate and then it'll come back down and start machining again. And oh, that's not good. G234 is not good. Yeah. Okay. So I missed gotta go back and edit machine. So that's what happens if you don't uncheck those TCPs in the machine definition, is you get that G234 and then the VF2 is going to alarm. So, okay, there's that. And then let's post it again. Every time it wants to go to the next gen control, but pre-NGC is the post we need. All these should still be the same. So scroll down here to, once again, all right, so now we're back here, contour number 5, and there's no G234. So that looks good. Again, we still have our safe retracts. Okay, so come down here until 7, A90, B90, A90, B180, and so forth. All right, so there we go. Now, one thing we didn't mention, center of rotation. Now that everything is one work offset, it's super critical that your machining assembly matches really going on in the machine, okay? Because you don't have the other work offsets to help you with, orientation. Um, if this is off, then when you start rotating, all that stuff's going to be off too. So center rotation is the most important for having your machining model match what's really going on in the machine. Okay, that's it for this video.